In this video, we'll look at two examples that has to do with an application of calculating present value. So the first one I wrote fully out, and the second one I tried to summarize it a bit, but we're finding the present value. It's important, and I highlighted it, that this formula that I wrote to the right here applies when it's a continuous stream of income or a continuous source of earnings. Okay, that continuous, and I underlined it, the E over here. Okay, that E and this formula is derived from the fact that it is a continuous stream of income. Okay, so also on the right, I wrote what all these variables stand for. So looking at this first example, it's over 5 years. T1 and T2 is the start and the end. So let's kind of multitask here. Over 5 years means I'm starting at year 0 and I'm going for the next 5 years. And most problems are this way, okay, over the next 5 years, or this example over here, right, over the next 2 years. So T1 and T2 is the start and the end. The K of T is the income or the earnings or whatever is being made here. It can be a function. In this example, it's $35,000 per year. It's not changing, it's not increasing. Over the next 5 years, that steady rate of income, right, is $35,000. So that's our K of T. And then E to the negative R is the interest rate, and 7%, right? We want that as a decimal, 0.07. And T is your variable, so we're going to integrate with respect to T. So this T is not 5. Okay, that's not the over 5 years. That's what the bounds on the integral are for, the lower and upper bounds, 0 to 5. Okay, so now we integrate. We have our variable here, right, the T. The 35,000 is just constant. We could factor that out. We pull it outside of the integral. So we're just looking at this here. So to integrate E, it remains E, right, E to the negative 0.07t. But then we divide, if it's a linear function like that, we could use the whole U substitution, but we learned this rule before. We divide by that negative 0.07. So I'm just going to write that out to the front here, okay, because that's also constant. And then we're integrating from 0 to 5. Right, much of this, just bust out your calculator. I often write out, as much as I can to save some calculator errors, but 35,000 divided by negative 0.07, we get negative 500,000. And then for the E, so we're going to substitute 5, right? E to the negative 0.07 times 5, so E to the negative 0.35. And then minus E to the negative 0, so E to the 0 is just 1. That's just 1. And that's really about all I could do in my head. I mean, I could distribute, but at this point, might as well just use the calculator. And we get approximately $147,000, $655.96. Alrighty, it's not too bad. Moving forward, I know that this one's going to take up a bit more room because I see that the income here is a function. So the integral is going to be a little more work. All right. So they make 30 plus 5t $1 million per year. Even at year 1 then, right? T is 1, that's 35 million. They're doing well. Compute the present value of the earnings over the next 2 years. So we arrange our bounds go from 0 to 2 the function is 30 plus 5t e to the negative 10%, so negative 0.1 t dt. All right. So looking at this now, thinking u substitution, right? We let the exponent on e be u, but du would be negative 0.1, and I have this whole 30 plus 5t here. We could distribute, all right, there's more than one approach to tackle this problem. I don't know, honestly, what is going to be best. So I'm just going to leave it as u. We're going to have to do integration by parts, right? Substitution just isn't going to work. So du, right, this is u, and the rest of that is going to be the dv. Right. So u du, so we get 5 dt, and then dv is e to the negative 0.1 t dt, and v, we know if we integrated that, right, to get from dv to v, we got to integrate. We leave at e to the negative 0.1 t, but then we divide by negative 0.1. So now let's take this. Remember, integration by parts gives uv minus v du. So this is equivalent to u times v, so 30 plus 5t multiplied by e to the negative 0.1 t over negative 0.1. And we range that from 0 to 2. Right, that was our bounds. Subtract v du. So e to the negative, well, we have a 5. Right, I could see that 5. Let's go ahead and just pull that 5 out now. You know what? And we could also pull out the negative 0.1. So we just have this e to the negative 0.1 t dt. Right? I took, this is constant, I just pulled it out. And this 5, no sense of leaving it in there, I pulled that out as well. Right? So now what's left here, and this often happens, right? What's left to integrate, we just did over here. Right, so I already know the result of that integral. This integral of e to the negative 0.1 t is e to the negative 0.1 t over negative 0.1. And then we still had the negative 5 divided by negative 0.1, which might as well make that a positive. That is going to turn out to be, you know what, I'll just leave it for now because I see this other 0.1. Right, ranging that from 0 to 2. And on the left here, so we need to substitute 2 and we need to substitute 0. So when we substitute 2, we have 30 plus 5 times 2. So it's 40 over negative 0.1, and then e to the negative 2 times 0.1, so e to the negative 0.2. Subtract, substitute 0, so we get 30, right, because 30 plus 5 times 0. And then e to the 0, that's just 1 over negative 0.1. Or we could just say all of this over negative 0.1. Save a little bit of calculator work. Okay. So moving on, not a whole lot to do here, right? All of this is going to require the calculator, so I'm just going to rewrite it. Minus 30 times 1, negative 0.1. Okay. So here now we have this negative 0.1 times 0.1. So I'm going to change it back to a negative over 0.1 squared. And then Now we'll substitute 2 in, we get e to the negative 0.2 minus substitute 0, e to the 0, which again is 1. All right, and you know what, that's pretty ugly. Let's just plug it all in the calculator. So I did it beforehand. We get about 63.1423. And depending where we want to round, this is in millions, you know, I guess 63.1 million approximately. $1 million. You know, if I had 63 million, I guess, you know, what's the 4 here? 40,000. Meh. Alrighty. Hope that helps.